Hi, welcome. We're going to talk about how to factor a difference of squares when it has a difference of squares, but also a greatest common factor. And in this case, I can see that 3x squared and minus 27, they have a common factor, and the common factor is 3. So 3x squared is the same as 3 times x squared. I could write that x squared as x times x, but I'll just leave it as x squared, minus, and then 27 is 3 times 9. And so what they have in common, their greatest common factor, remember they always have a greatest common factor of at least 1, but this one has a greatest common factor of something greater than 1, which is 3. And I can factor that out as a 3, and that's 3 times x squared minus 9. If I were to use the distributive property, that would go back to what we had before with 3x squared minus 27. And then I want to see if I can apply the general factoring strategy of factoring a difference of squares. So I've got a squared minus b squared. I need to figure out what my a is, what my b is. And once I do, I can write the factor of these two terms as a and b, and then with a plus and a minus in between them, or vice versa. And so here I can see that my first term, x squared, is just the square of x times itself. And the second one with 9, I can say that's the same as 3 times itself squared. And so now I know what my a and my b are. I can write 3 times, and then my two sets of parentheses, write x and 3, x and 3. And then you just write a plus and a minus in between them. And that would be completely factored for this problem. Now, if we look at the next one here, we've got 50x squared minus 32. I want to go off to the side here and say, what's 50 and 32? What are their common factors? So I'd break them down into their prime factors. 50 is 2 times 25, and 25 is 5 times 5. Whereas 32 is 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. And so I see there, what do they have in common? It appears that they just have the 1, 2 in common. And so I can factor that out. I can write 2, which is this 2 that I have highlighted over here. And then I ask, what do I have left here? What do I have in common? I have the 2 5s with the 50. So 5 times 5 is 25 with the x squared. In this case, they don't both have variables, but you also want to check to see if they have variables in common that you can factor those out also. This one, the left term has x squared, but the other one doesn't have any. But you do always want to check for that. And then I've got minus, and when I took this 2 out, I was left with these 4 2s, and I multiply those back together. 2 times 2 times 2 times 2 is 16. And so then I have 2 times, and I asked myself, what do I multiply by itself to get 25x squared? So I can figure out my a value, and that would be 5x squared. 5x times 5x is 25x squared. And then I've got minus 4 squared, because 4 times 4 is 16. And now I know what my a and my b values are. I can write 2 times 5x and 4 and 5x and 4, and put a plus and a minus. And now this is completely factored. So that would be my answer if I was asked to factor this thing completely.